Again, we had a minor problem, technicalities with the class recording. I think we've got it solved, and the videos will start showing up uh, tomorrow, probably tomorrow afternoon. So if you want to go back over them, you'll be able to do that. Today, we're going to take the results of the survey and we're going to do a boot camp on what people felt they needed reviewed on. If you're comfortable with everything that we're going to talk about, you're free to leave before we get started. Uh, Make sure you come and sign in next Tuesday and Thursday, and next Tuesday. Next Thursday, we'll actually start Chapter 9, and we'll take a look at that as we go through it. This is the rankings from the surveys, and I did your class, and I also did my online class, and surprisingly, they were pretty much the same. Modules and functions came in at 75%, so we'll be doing that. Dictionary capabilities were at 54, pickling at 55, files at 63, and data types at 49. So with that in mind, this is how we're going to approach all that. Today we're going to take a look at data types and files. And for those of you who have not done PyCharm, we'll do just a real quick, this is how we start up PyCharm so you're comfortable with that. And if those of you who didn't have me that want to talk about downloading it, stay after class for about 3 minutes and I'll give you a quick heads up on that and give you some assistance if you need it. Then on Tuesday, we're going to take a look at dictionaries and pickling. They kind of go together, and they're very good tools within Python. And then next Thursday, a week from today, we're going to start with functions, and that will lead us into Chapter 9, which is modules. And Python is delivered with the standard library. That standard library contains, I don't know, a couple of hundred different types of modules that we can use in the program. And there are little code snippets that we can call from any program, any script that we write in Python. And so it's repeatable things that we can use. A sample of one that you may have experienced before is the print module. That's actually a module within Python, and every time you type print, parentheses, quote marks, hello world, it goes to that module and understands what to do. Kind of a cool thing. In fact, that one's read into memory. So this is how we're going to start, and we'll go from there and hopefully then be able to proceed on. So that'll keep us on track for what we want to do this semester. I told the folks who were in my fundamentals class that we were going to get more into Gen Cyber and Gen Cyber related issues, and we will. And what we'll do is look at a chapter in the textbook and then apply that to the Gen Cyber security functions that are in Chapter 12. So hopefully it will keep you interested for this semester. All right, we'll start with data types. Anybody want to leave, feel free to go. Very good. Or if we get partway through it, not the whole class leave, but make me feel bad. Variables can be in Python. They can be letters. They can be numbers. They can be underscores. But a variable in Python cannot start with a digit or special characters. All right. So when we talk about some of the rules in Python, when we look at variables, and understand in Python we treat variables a little bit differently than we do in Java or C# or C++. Or some of the other 4GL languages, or even in SQL for that matter. In Python, our data variables can be any length. All right, so we can make them as long or as short as we want to. So with that in mind, if I was going to create a variable to represent sales tax, instead of putting, you know, people must eat these darn things. Let's try again. I lectured last night in the accounting classroom. They had two colors of markers, black and red. Never mind. Now this will almost work. Let's hope not, but, and sales tax, sales underbar tax makes a whole lot more sense than ST. That could be almost anything, all right? So within Python, with the computer systems that we're working on here, and I'm sure yours are more powerful at home, go ahead and spell out what that variable is. It makes it a whole lot easier. I go crazy sometimes when I look out on the internet for different ideas and things that we can do in class to show you different applications of Python. And they'll go through and all their variables will be one character. You start to get lost when you go through it. So your variable can be any length and use it to spell out. It needs to make sense. So sales tax, if we look at that variable, we know exactly what sales tax is. We can figure it out. Another one, and I was, can't remember the program I was looking at. It was actually, yes I do. Actually, it was the different scanning programs we can look at to read your ID cards. And one of the programs I looked at that was in Python used FO for file open. Okay, I was in the Air Force for 27 years. FO means something totally different than file open. If you don't know, see somebody after class that's laughing. They'll tell you, all right? So it's got to make sense, all right? Why not just use file open and never mind. All right, we can also use camel case. Whoops. Camel case, that is a very appropriate usage. And usually, my rule of thumb, I'll use camel case when I'm going to run the letters together. So as an example, my expenses. All right, so camel case means we capitalize the first letter of each word. Now, in Python, the Python community, I mean, for crying out loud, we were named after Monty Python's Flying Circus. So Python community is a little weird. Now they watch a lot of IT Office, but that's a different story. But when we're using variables, the Python community says all variables should be lowercase. Okay, I can get along with that sometimes, but if they can be if they want them all lowercase, why do we say? But it's okay to use camel case. All right, so use your judgment. But generally speaking, variables in Python are written in lowercase. If we have a constant, as an example, the sales tax here, if this is a constant and it's always going to be 25%, then the Python, oh, this one works. The Python community says sales tax should be all caps. All right, I'm not going to hold you to that. I will hold you to your variable should make sense. But again, we're looking at some of the Python things. Yeah.
Python said if it's a constant, it's going to be all caps?
Yeah.
Okay.
Yeah. That's the Python community. All right. Python, the program, doesn't give a darn. As long as you take care of it, it'll do it. And so those are some of the things that we want to look at when we talk about variable creation, which leads us into what was one of our most demanded topics, and that is data types. And so we'll look at the different data types that we have in Python, but what makes Python really unique among all of the 4GL languages, in my impression, is that Python, our data types are self-defining. That means that I don't, like I do in C#, I don't have to state that a variable is going to contain a numeric value, or that a variable is going to contain string characters, alpha characters. All right, so in Python they are self-defining. So in that case, if I look at my sales tax option here, immediately Python says, oh, okay, sales tax is a float because it's a decimal. We'll cover that in a couple of minutes. And it's also a numeric. All right, so it's a numeric float. And having done, I don't know, many years as a C# programmer, that was kind of hard to get used to. What do you mean? I can just tell it what to do and it'll do it. How refreshing. All right, so Python is self-defining when we talk about our variables. We're going to look at, there are a variety of different variables, but what I want to look at are the common types that you're most likely to encounter in our class or when you go out and use this with Ken. And probably the most common is a string variable. And a string variable in Python is generally defined as a contiguous set of characters, you know, like A to Z, or now is the time for all, fill in the rest of the blanks. And that string is identified by being set off in quotation marks. Now, we talked a little bit on Tuesday about quotation marks, but within Python, it is totally acceptable to designate a string by using single quote marks or double quote marks. If you use double quote marks and your text contains apostrophes, then you don't have to do anything special. You can just type it in and go. So if you use double quote marks to define a string, that's a little better option than using single quote marks. If you use single quote marks, you have to add additional coding that potentially could go wrong to indicate any apostrophes you might use in that text. So, and you're more than welcome to do either option as long as you get it right. That'll work well. Let's see, a couple of things that we can talk about when we talk about our string variables. And again, a string is going to be found off the side of the road daily. So that's the way a string is going to be designated. I'm sure that's just a quick review for everybody. But in addition to that, what's unique about a string is that we can index a string and we can call out each unique value within that string. So if our string equals our good old standby, we can index each letter in our string, and we can call that letter out and print it out or modify it if we need to. Remember, in strings like in counting in Python, we start with 0. Our space is counted as number 5. So if I want to refer to the W, I could do something like this. Okay? And we're seeing where our string is, so we can go through and take a look at that index. And so that helps us. You can design a really complicated program if you want to that would go in and substitute based on index values of a string, but you need to have a way to keep track of all that. So while it's something that we can do, I don't recommend it. There are better options that we can do that. A couple of other things about strings that are interesting. If we can put numeric values in strings, we have to be careful in putting control characters in strings because they may mean something in Python. And as an example, if I put in a control N or a backslash N escape sequence or a backslash T or a backslash R, those all mean something in Python, even when they're included within the quotation marks. So you have to remember that, and if you get odd responses on the code that you're writing, that may be one of the reasons that you're seeing that odd response. Let me see what else. Sequence, yep, okay. So the next one we want to look at is integer float. And we talked about, that's odd. Huh, okay. Should be integers and floats.
The next slide has these integers and floats.
Yeah, I know, and it also has in lists. So somehow, oh well, we'd still do it. What you all don't get to see is I have my cheat sheet notes, and when I changed the slides, my notes went bye-bye. So this will wing integers and floats. Again, we know they're self-defining. Integer is a whole value. A float is a whole number. A float is going to contain a decimal. And so if I say tax equals 1.2, then tax immediately becomes a float, and I can work with it. Going on to that, I can add an integer, a non-float number to a float without any problem. All right, and that would be very easy to create. Let me see if I can figure out what else I wanted to talk about. Oh, along with integers and floats, we can also do hexadecimal if we want to, and we can calculate in hexadecimal, and there are actually modules within Python that'll let us print out hexadecimal. Normally speaking, we wouldn't encounter that in the scripting class. However, if you're going on in Ken's program, are going to go over and survive Dr. Shenoy, hexadecimal is going to become second nature to you, and Python will allow you to work in hexadecimal. So again, it's fairly simple. When we talk about integers or floats, we can do all the common math functions: add, subtract, multiply, and divide. Hopefully everybody remembers the symbols plus and minus for add and subtract, asterisk for multiply, and a / sign for divide. And that should be fairly simple. As we're going along, if you have any questions, please ask. Okay, so we've looked at strings, we've looked at floats and integers. And I killed that one for sure. Next, we're going to take a look at lists. And interestingly, several lists was up there about 36% of both classes wanted to take a look at lists just separately. So we'll take a little bit of time and look at lists, and then when we go into the hands-on function a little later this morning, we'll get in to lists a little bit more and play with them. So the basic thing to remember about a list in Python is it's an ordered sequence of items. And you're going to find out that this is probably the most versatile variable within Python that we can use. And the basics are that we create a list by using square brackets, and we separate the elements within a list by commas. So if I want to create a list, I use my square bracket, and that creates a blank list like that. All right, and then the program could fill that in. If I want to create a list and populate it at the same time, because Python allows us to define as we create, my list items will be included inside square brackets, and the alphanumeric values will be included within quote marks. I can also put numeric values in my list and not do anything different. Just enough room. Now the unique thing is that in my list, if I call 1, if I call element 0, which is the character string for 1, I'll treat that as a character string. If I call the numeric value 1 out of the list, I can treat that as an integer. So that's why we say within Python we have some, it's really one of the most versatile tools that we can use as we're working with Python. Again, to use the proper language, each element within a list, or each item within a list is called an element, and like a string, lists are indexed. So we would do 0, 1, 2, 3, 4, 5. All right, and we can call that list element if we need to. Yes, sir.
And that's not required to be in parentheses or anything like that. The list is not at all.
Yeah, that's how we define it.
Okay, cool.
Yeah, we have to use the square brackets to define the list. How many?
The tuples, what is the difference between the list and the tuples? I know they're faster, I know the tuple you can't change it, but does it treat the integer as an integer?
Yeah, I think it does.
Oh,
I'll check.
Let me try it.
Okay, we're not doing tuples.
Okay.
Okay, we'll talk about those later.
If I had to guess, would it be the same as, like, I know don't talk about C languages when you're in Python. Is it the same thing as arrays versus vectors?
Yes, exactly.
Okay.
Exactly. Think of the list in Python as an array if you've been in the C languages, or if you've done even Visual Basic. okay? The difference is in an array in C, we can have rows and columns. We can't in Python. Okay, we could artificially create them, but if we were gonna, actually, this is kind of like an array in C, but the dictionary is probably more like it. And we'll see that next week. Or has more of the functionality of it. Garrett, were you going to ask?
No, sure.
Okay, stretching is allowed. Okay, we said it can contain a combination of different data types. Things are referred to by their numbers. And then when we talk versatility, we can remove a single item from our list with our index number if we want to. Or we can append the list, or we can determine the length of the list, how many items are in it, or we can go through and say what's the maximum or what's the minimum value contained in our list. In addition to that, we can count the items, we said that, or we can also sort the items. So we can sort them in different ways. And of course, we can always append to the list. So again, this is one of our more versatile data types that we use. The next one we'll talk about is the dictionary. And we're going to jump into that a little bit more as we look at classes. And that's in chapter 10. So we'll talk just a little bit about dictionaries now, but you're going to get more than what you want to hear about dictionaries in chapter 10 when we get into classes. Dictionaries in Python are an unordered set of data. And what blows people away sometimes is that they will create a dictionary, save it out to a disk file, read the file back into the data or back into the program, and the dictionary is in a totally different order. All right? And Python tells you right up front, it is an unordered set of data. Now, with a dictionary, and again, we're just going to touch on this lightly, but with a dictionary, we have what we call in database development a primary key that will uniquely identify whatever it is that we're talking about. So we may have a car color. All right, and so a color for a specific car would be defined as red, and that's kind of like how we define it. Again, we're going to get further into that. The unique part about a dictionary, with a list, we store our data in what you want to think of as a stream. We have to look at that data from 0 through 1. With a dictionary, we can look for, as an example, color as a key, and then bring up color for anything that, whatever the object is that we are storing. Like lists, I can create a nested list, and it gets complicated to work with. In a dictionary, I can create a nested dictionary, and that means a dictionary within a dictionary. So the best example I could give you of that is I could create a dictionary called Scripting Students. Within that dictionary, I could create a nested dictionary that would identify each of you. And then within your dictionary, I could create a nested dictionary that represented each of the grades that you got in the class. Trying to do that with a list would drive you nuts. It's just almost impossible to think about. But again, when we get into creating classes, that's where a dictionary really comes into play. And what you're going to see is that dictionary is very, very valuable to us, but it reaches a limitation within Python when we start to talk about classes. And then we'll see, you have to come to that series of lectures to find out the magic behind that and what we can do for it. Dictionaries in Python are normally used for large amounts of data. I think one of the things that a lot of the tutorials and examples and textbooks that you'll look at when we talk about dictionaries fail the students on is they'll give them 3 or 4. One of the examples that I still remember from when I learned Python is they talk about there are people at a party. Oh great, how many? 4, not much of a party, and they're all going to bring a fruit. Oh boy, really? Joe brings apples, Sally brings oranges, and that's the dictionary. What does that tell you? The person who wrote it probably didn't have a big social life. But dictionaries in Python will handle huge amounts of data. And we can store it, and we can read it back in, and we can manipulate it if we want to. But I'll show you some tricks with that when we get further into Python. When we create a dictionary in Python, we use a brace. And again, we'll get deeply into those in just a little bit. So those were data types. The next thing that people were interested in is file operation. And normally your books will talk about reading and writing to a traditional disk file. But we can read and write to a portable hard drive, a thumb drive, your Google Drive. By the way, and you might look down on the control panel on your computers. Roy thought they may have turned on deep freeze in these classrooms. If you're not familiar with deep freeze, if you save a file on your desktop in the classroom, once you log off, the computer totally rewipes the memory and the hard drive and reinstalls the image, and your file is gone. So all of you with a email at rader.rose.edu, you have 5 terabytes of storage available to you. So what I've recommended, especially my digital fabrication students, to do is store all your work out on your Google hard drive. And you can set that up, you can go to it, you can using a browser, I found out the hard way, they prefer you use the Google browser to access Google hard drive, not Microsoft Explorer. But you can actually drag and drop files into folders out there. In fact, in the digital fabrication class, Olivia is going to find out that we'll create a shared folder where everybody puts their homework because the files are so large. But just a point for here. When we talk about files in Python, let's talk about the name creation first of the file. And again, like our variables, the file name should be descriptive. It should tell us what's in the file. If I'm going to build a grade book for scripting students, then I want to store that grade book as Tuesday, Thursday scripting students, or some kind of identifier that I want to use. One of the things that we kind of take for granted with Microsoft, Microsoft always uses, or almost always uses, a 3-character extension. DOC, XLS, what do they use? MDB, TXT for text. And in Python, there are times when we do it a little bit differently. As an example, when we talk about pickling, the standard's not the right word. The desired way to indicate a pickled file is give it a name, students.p for pickle. And anytime someone in the Python community sees that .p, they realize that it is a pickled file. And if you don't know, a pickled file is written in binary and you just can't open it up and read it like a text file. All right, you have to take a special look at it. Some other extensions, of course, .txt if you're saving text documents. If you've indicated a list, you might save it with the extension LST. That would be fine, of course. DEC for decimal, HEX for hex. And so you can think about that, and those are some of the extensions that they look at. Again, the file name, make it as descriptive as you can with all of the conventions that are required by the operating system that you're using. When we talk about file operation, we use a read and write function in Python, and we refer to this as a dis function, even though it may be strictly, it may not be the traditional hard drive or optical drive. All files that we're going to work with in Python start with the open argument. Whether we're going to read to a file or write to a file, we're going to open. And with that, one of the nice, easy things when we talk about Python allowing us to define variables on the fly, once I define the file that I'm going to have open, I can then refer to it in my text as open file. And so that gives us a really unique way to do it. In some languages, you actually have to give the file location every time you want to write to it. And that's not any fun at all. So we use an open argument to write for the file. And then what we want to do is give our file name. So we use double quote marks, single quote marks will work too. And when we give the file name, we also want to give the directory location that we're using. So if I just want to write to the C drive, I can do it that way. So it'll look at that path and recognize it. Now, there are three primary options that we can look at when we work with our file. And those are RW and A. R for read, W for write, A for append. And each one of those has some unique operators underneath it, but we'll start with these. And if we want to write to a file called new students, we put a comma after the file name, and then in quote marks we put the operation that we're going to do. Now, that's read, W for write, and we'll go from there. Now, obviously, if we're going to read a file, it's already in existence. But if I change this to a W, to write, or an A to append, Python will create the file for us. This is a love-hate relationship, because if I've already got a new student's file in my directory and I put a W in, guess what's going to happen to the data that was in there? Poof. Yeah, it's gone. All right. So we need to be careful. as we do that. The append function will add information at the end of the file, generally speaking. The read function will generally start at the beginning of the file, and it'll read that file as a stream. It'll take the data, whatever way you set it up to read, and it'll go from there. Tell me.
Do we have to can we only use one, or can we use like write and read, or write and append?
Good question. That's what I'm going to cover next. All right. So, my write function, I can also have write B, which is write binary. So when we're working with our pickle file or our dictionary files, we're always going to write binary, or we'll use pickle when we do that. I can also have W plus, which means I could read or write or append if I wanted to. I can have A for append, binary, or believe it or not, A plus, which lets you do everything. And of course I can do R plus, and RB, and AB, and A. So we've got several different options. You can take a look in, I think it's chapter 6, and there are even more than this. You can go through and take a look at them and see how they operate. Let me see, what do I want to say here? Yeah, I think that covers that. Any questions on that? Primarily what you'll do, normally what you'll do is you're going to, the best way if the file is open is do a either an R plus or a W plus as you're going through to get a feel for what you need to do. Hang on one second so I don't forget. If we don't define a directory where we want to store our information, if we just create our write statement like that, it will store your file in the directory that it's writing your Python script to. So if I created a file called, or a Python project in PyCharm called class 4, and I create a file called quiz grades in there, and I want to write those quiz grades out to a directory, it will write it to that class 4 project directory. Now, those of you who haven't used PyCharm yet, I'll show you, we'll see how that works here in just a couple of minutes. Oh, we still have time. Any questions about files or anything I didn't get right? Help me.
Just can you repeat? I just forgot when you put the W, it will, or something will happen. Then it will remove the data in the file.
Right. If you set your file up like this, the example on the board,
Okay.
and there is already a new student file in the directory that you're going to write this file to, using just a W will recreate that file and you'll lose all your data.
Okay.
Okay? Okay, got that. All right, hands-on. Go ahead and for those of you who know PyCharm, go ahead and open it up. You will notice that we have gone to a different edition. We're off of the community edition. For those of you new to PyCharm, what you want to look for is something called JetBrains in your program file, and underneath that you'll find the new edition of PyCharm that we're using. And when you find that, JetBrains, and open it up, this is similar to what you're going to see. PyCharm version 2016, it'll give you the build numbers that we have on it. You may not see anything on the right-hand side, or left-hand side, your left, because you haven't created anything with the program here in this classroom. And your options will be create a new program or a new project, open, and check out the version control number. So everybody found it, have the software started. All right, if you're new to it, create a new project. It'll give you a default location where you want to store that project. And again, if you have a thumb drive or you want to try and get it out to a Google Drive or the desktop or whatever, you can fill that location in. You have 3 dots for the browse button. And what you should see is, under interpreter, is Python 3.5 dot something. And it depends on the build that they put on the image for this classroom as to what it would be. If the interpreter is blank, click the drop down arrow and it should list the interpreters that are available on the machine, and check the one that's 3.5 dot whatever. By the way, if you want to create a directory, as an example, maybe the directory for class 4 isn't created. I could actually type class 4 in here and PyCharm would create that directory for me on the fly. So it's kind of a nice function to have with PyCharm. There you are. You can see it a little closer if you need to see it closer. One of the community standards, if you will, when you're working in Python is that you create a folder somewhere called py for Python, and then within that folder, that's where you store all your Python projects and scripts. Do whatever you want to do, all right? Make it work for you. And we can talk, for those of you new to PyCharm, we can talk about setup and so on after class. And so once you have the file created and the interpreter set up correct, you should see the programming screen. It'll have a console on it, and you should see a navigation window. If not, you may have to turn it on in the view, and it'll list the project that you just created. The example I'm using is Scripting Fall 2016. And so if I right-clicked on the drop-down arrow, it would show me all of the different scripts I have under that, or within that project. But since we're starting off new, what I want to do is right-click on that project name. This flyout menu will come up. We want to select New, and then from New, we want to select the Python file. Notice by default, we can use this to create just a plain old text file. At this point, we can still create a new directory. We can create a Python package, which, if we have time, when we do our keylogger, I'll show you how to do that. And that's where you can create a deployable application that If you were doing key logging, you'd want to sneak onto somebody's machine. We'll talk about that later. Obviously, Python, we can do HTML by default. Once you do that, you're going to be asked for a name. Again, the kind should default to Python file, and name it anything you want to name it as long as it's descriptive. In this case, I made mine Hello World.
So you right-click on project files.
Yes, ma'am.
It says the top thing is select next view.
Okay, let's go back. Right here. Right here. No, on the. Yeah, it's on the color of the file, or the project. There's a blue bar on the project name. That's where you're going to right-click to get to this. And so once you've done that, then you can write your first script. You'll have a console over on the right-hand side, your navigation on the left-hand side, and down at the bottom you have the actual Python display console when we run our scripts. Now, here you should see a tab if you've gone ahead and set up to create your first script. And let me talk to you a little bit about lines 1 through 4. In line 1, I actually set up my Python files to put a comment in with a bang sign, that's an exclamation point, a space in Python 3. And what that does every time the interpreter runs is that it tells the interpreter you can check for whatever versions of Python are on this computer, but always run this script in Python 3. If you don't include number 1 and you run the script on a program that, let's say, contains Python 2.7.2, it may try and run it in 2.7 first before it would find Python 3, depending on what your system path says. And so this is just a way to make sure that it's using the current version of Python. Notice it just says 3, it doesn't say 3.5.6 or anything like that. We're just looking at the major version release. Number 2 automatically puts in my name. All right, I've asked you all when you turn your scripts in to make sure you have your name at the top. If you set up PyCharm to do that for you, when you're creating your files, it'll save you time. And then line 3 is a reference for me. I know any script with that I created during fall semester 2016. And then line 4 is another thing I put in. It gives me an automatic variable of double underbar date, double underbar, and equals, and this is automatically filled in by the machine. And once it's filled in, it'll take the date of the computer or the network you're on. It won't change. So if I need a reference for when I created the file, I can see it. If I need to reference the date within the script I'm creating, I can also see it. Lines 5, 6, and 7 are just good programming techniques. You should write a description of what your file does at the very top of the file before you start working. We'll see when we get into some of the more sophisticated things in Python that we're able to pull those descriptions out and read them without opening the file up. So it's a good habit to get into.
Can you show us how to do the, where you make the stuff automatically print up there?
Yeah.
Real fast?
Yeah. Well, not real fast. I'll have to bring Python up, but yes, I will. All right, and then For those of you new, you just start typing your code over here. It has IntelliSense, so it will predict what it thinks you want to type in. It will also give you red squiggly lines to tell you, whoops, you made a mistake, or at least I think you made a mistake. It also has a limited spell check, so if you spell a word wrong as a variable, it'll underline that for you too, or gray it out, or give you an idea that you made a problem. So give me a second and I'll get Python started up on the console and I'll show you how to make those changes.